Hi guys, right now I'm working on a 2007 Ford Econoline E-150 van. Um, so this is actually my work vehicle, and last Friday I was working. It was super hot outside, and I go into my vehicle to do some quick lunch, and my fan stopped blowing. So what I'm going to do right now is attempt to diagnose why that went down, and you know, see if we can resolve the issue and possibly get this thing back up and running and blowing some air. So keep us cool at least for a couple more weeks while this summer goes away and we approach fall. So let's check it out. All right. So the first thing you want to do, or I should say, what we want to do is I pulled up a diagram, and we want to look at this. The circuit for this HVAC system. So looking at this thing, we can see that we have a couple fuses here that we should be checking. There's a 50 amp fuse in the junction box, probably under the hood, and we have a blower motor relay here. Also, we also want to check a 15 amp fuse, and I did some research. That one is actually under the driver's kick panel. There's in the instrument panel area. Basically, we want to make sure that that fuse is good. We want to check this fuse here, make sure that fuse is good. Also, we're going to check to see if we're getting power at the relay, and to see if when I turn on my fan switch, to make sure that we're actually getting power to the other terminal, and to see we're getting control there. So as you can see with this diagram, we get power all the way through here, and your switch here for your fan switch, actually it's not even your fan switch, this is your vent switch to figure out where you want the air to go. This will get power here, and then you have control here, power that goes all the way up, down, supplies power to your relay, grounds out on the other side. It'll pull the switch closed here, which will supply power to your blower motor, and then here your blower motor is pretty much grounded out through this circuit and through your fan switch to see how fast you want the air to blow, and it'll ground out through there. So these are things that we're going to want to check, make sure we're getting power in all the right places. And then the thing is too is that if it was the blower motor resistor, we would have power, we would at least have a high fan speed normally. So we don't even have that. So my main concern right now is to make sure we have power going from all these places and nothing's popped, like a relay is bad or fuse. And then we're going to check the blower motor to see if we have power on one end, and see when the circuit's loaded, if we're getting power on this side of it. And then what we'll do after that is we'll actually even supply power and a ground to the blower motor and see if we can manually turn it on. And if it turns on, then we know that the blower motor will be good. If it doesn't, that's probably going to be our issue. So I'll take you over and we'll do that next. Okay guys, so the first thing we want to do is let's check the fuse here. It looks like fuse number 17, and it's a 50 amp fuse. Our power distribution box here gives us a nice little diagram. So fuse 17, 50 amp, let's see, 17 there. And if we look down here, 1, 2, 3, 17. 1, 2, 3. But we have a 60 in there. I don't know if that's right or not. It's obviously, oh, dumb. I guess if I was looking at this the right way. So 17, this is actually backwards. This is more like this. If you can see that. So if that's number 17, we got 1, 2, 3. There's our 50 amp right here. So I got my test light. I'm hooked to ground over there. You can see it. So what I'm going to do is check both sides of this. I have the circuit on right now, so the fans are on, AC's running, and I got power at both ends of that switch. I mean, not that switch, but that fuse. So we know that fuse is good. Next thing we want to check is our blower motor relay. I don't know why you can see that. Blower motor relay, and I believe when I was looking at the book, it shows here that it's going to be number H, which is this guy right here. Okay, so don't mind that wire. That wire's for my power inverter. So just to show you guys that our fan is on. Oh, fan's on there, and we get no fan going, nothing here, and none of these modes. So we got fan running there. So actually, this is what we're going to do. We want to turn that off just so I can show you that we get power to it. So one of these is going to have power all the time, and it should be pin 30 is our switch. So it's gonna be should be this guy that has power all the time, based from our relay diagram. Okay, so that's gonna be our power. And then what we want is to be able to turn on fan here. Just put it in that one. And this is basically just checking control, make sure that we have control, and there you go. So now we got power at this one and this one. And let's see if I can actually leave that there. I'm gonna go inside and turn off the fan. Just let that sit there. I'm gonna go turn off the fan, and you'll see that light turn off. Tell me what you guys see. So as you can see, the light turned off. I'll turn it back on. So there it is. So we have good control from the switch to this power distribution box. I know this relay is good because I changed it out before with a known good Ford relay. that we had laying around, well, that I had laying around, and so we know that this is good. So I'll plug this back in. And we're still not getting any fan operation. So we checked that. Now the next thing we're going to want to check is this fuse number 13 that's going to be under the instrument panel. It's a 15 amp fuse. Let's go there next. Okay guys, so I got you underneath here, under the instrument panel. So I got the test light hooked up here. Fuse number 13 is this blue 15 amp right here. We got power on that side and power on that side, so that fuse is good. And of course this is with the circuit loaded, so we have the fan switch turned on about a medium speed, and we got power there. Alright, so the next spot we want to go to is the actual blower motor itself, which in this vehicle is to the left of the engine compartment. Yeah, the engine compartment, and so it's right behind the battery here, and it's going to be this piece here, this component here. This is your blower motor assembly, and our connector is down in there. How well you can see it, let me see if I can point it out. It's right there, you can see the connection. To the right, that yellowish connector there, that is going to be your resistor for the fan speed, and but what we want to do is we want to check that 2-wire connection there. According to our diagram says we're looking for a pink and black. Oh, I'm sorry. We're looking at it for an orange and red and an orange and black. And when we look in there, I definitely can see an orange and black, and the other one's kind of dirty. It's kind of dirty in there. I can't really tell what it is, and I'm trying to get you guys a good lighting in there. So I'm going to pull that connector. I'm going to see if we got power at either one of those sides. We should, being that our relay is good, both of our fuses are good, so we should have power, and we should have ground on one side. So let's go there next. Alright, so let's unplug this connector here. Don't have a lot of room because this battery's in the way. Alright, so as you can see, I got the connector disconnected, so we're going to check for voltage here and make sure that we have power at this connector. Alright, so I got the voltmeter hooked up. I'm just going to check to make sure our ground is good here. We're hooked up here. We're reading 12.22. I'm good with that. So I want to grab this connector. What we're going to do is touch on both terminals and see which is our power side. There it is. So we got power to that connection. That's on the right side of our terminal, or of our connector. So that guy is our power side. This is our negative side. So what I'm going to do, and then when you touch on the negative side, if you look at our ground, we're reading 4 milliamps. So we know we got power at the connection. So the next thing we want to do is we want to test, see if we can supply power to that blower motor assembly. We can also do a resistance check and see if that's actually maybe an issue. So maybe we might as well do the resistance check first, see what that's reading, see if I can get my test leads down here. It's kind of tight with this battery in the way. I don't know if I'm going to be able to do this. It's really tight. Tight like a toiga. Is there any Austin Powers fans out there? Great movie. Alright, so... shoot. Okay, let's see here. Just gonna get on one terminal. Can I do it? I don't know if that's a good number or not, or if I'm even touching it. I think I am. But it's moving around on me, so we'd have to check the resistance of this blower assembly, but I think I'm on it. $490 ohms, 480. Moving around here. It's really tight in here, guys. Okay, well, I'm good with that. So what I want to do is I want to hook up a battery pack or something with 12 volts to that blower motor assembly, and let's see if we can energize it manually by supplying 12 volts to it. If it turns on with 12 volts, then we just got to keep hunting. If it does not, this thing's going to need a new blower. So let's do that next. Alright guys, so right now I just removed the battery just so we got a little bit more room to energize this blower motor. Right now I got my trusty little jump pack here hooked up to my voltmeter, just to show you that we do in fact have a 12 volt source. So I'm going to turn this on. So we got 12.5 volts there. So let's go ahead and hook up our jumper leads, and we'll see if we can energize this blower assembly manually. Try to do it safely without doing any harm or anything. That's the main objective. So we're working right here, guys. I'm gonna put some alligator clips, and I might actually do this different. Ooh, and actually the terminal inside the blower is actually super loose. Don't know how well you guys can see that. My finger's kind of messing it up, but I'll grab this alligator. Look at that. Look at how that's wiggling. This one, that one's solid. That's on there. So that could be our issue there. So this is what I'm going to do. We'll hook that one up. That'll be our negative. And for the positive, to be safe, I'm going to hook up my test lead to positive, so that way I can just poke this other terminal. So as you can see, we got 12.5 volts on our meter here. That's what we're going to supply to this blower to see if we can energize it. Let me turn on my jumper. And as you can see, we got nothing. We got a little bit of a voltage drop on the meter. When I lift off, 12.52, I go on it, 12.38, but it does not energize. Let me try to wiggle this terminal. Nope, nothing. The contact in that is demolished, so what I'm going to call right here, we're looking at, is a blower motor assembly. This thing needs a new blower for this thing to work. So when I can get a chance to get that installed, I'll make another video to show you guys that it is in fact working, and that was the right call. But this thing is going to need a new blower assembly. So just to wrap up, 2007 Ford E-150 van. Condition was the AC fan does not blow. So what we ended up doing was we checked all the fuses, the relay. We got power to all the fuses. None of them are blown. The relay, we got power to the relay. We have control of the relay, so we know that the switch is good, and we're getting control to our power distribution box. Next step would be to, what we did was energize or test the resistance of this unit, and it was sporadic. And then also we tried to manually energize it, supplying a 12 volt power feed and ground to this blower, and we got no response. So this guy is definitely going to need a blower assembly. Alright, thank you for watching. I hope you guys enjoyed that one. It's pretty quick, easy. You know, checking your powers, checking your grounds, supplying 12 volts to the component to see if it turns on. Yeah, so as soon as I get a new blower assembly in this thing, what we'll do is we'll you know, do that test again, supplying the 12 volts, see if we can turn it on manually. So, you know, just so that we could show that that in fact is a good test to condemn the blower assembly. But yeah, this was fun. So again, thank you for watching. My name is Gabe Perez, and we're out here. You know what I mean? Yay! Later. Real quick, guys, so I can get a better angle here, checking the ohms of this, checking the resistance of this blower. Now that the battery's out, so I just want to show you guys a good reading. And we're looking at, you know, 4 kilo ohms, 4.472, and it's fluctuating. And you know, I'm just curious. I'm going to look up to see what the actual resistance of this blower assembly should actually be. But I mean, it's real sporadic. It's all over the place, really. you know, check your leads, you know. Yeah, so I'll have to check that to see if that's even a good resistance. I doubt it, you know, given that this terminal's all wacky, and you know that one's pretty sturdy. The left one's wacky. The right terminal's nice and sturdy, and you know, we'll leave it at that.